Hello, and welcome to this session on the key principle for using control chart effectively. Now, you may be coming from an environment where historically you've been using Excel or some other visualization packages to plot how your process is performing over time. So something from what's on the left here. What I'll be talking about is some of the fundamental assumptions, rules, and thought process you need to pay attention to before you start moving to a control chart type environment, which hopefully will be useful to further improve the management of your process performance. Now, this is a fairly big topic, so I've purposefully chosen to split it in multiple modules as part of a series. They're built on each other. There's a small amount of repetition between all of them just in case people come into a particular video independently. So with that in mind, today's session, as I say, is really going to be focused on the what, the why, and that element of preparation toward building your control chart. Now, if you've not had a full CI training before, I'll take 2 seconds to explain a little bit what's behind process control and SPC. The idea is if you give a tool that helps the team visualize how the process is performing, because especially when there's lots of parties into this process or they're not actually seeing the process itself, they need something that they can relate to. And a graph, as you know, is very useful to share that information. So it's really about creating the sort of charts that will enable you to identify when something is about to go wrong or has gone wrong, but hopefully much more effectively so that you don't overreact when you shouldn't. And that's the case we refer to sometimes as random variation. It's just inherent to the process. We have to deal with it because that's the nature of it. On the other hand, there could be really excessive variation and you need to react, to go at minimum investigate what happened, because that can give you some learnings on how you can make your process more robust and reliable and create better experience for your customers. Or if you're in an environment where you are doing some process improvement, it can give you that visibility to monitor how the process is performing after you've carried out those changes. So on that basis, the how then becomes the relevant part. Again, I'm going to split it a little bit in two, where today I'm going to talk about the key principle, and then the other companion video will talk about how to build and analyze each chart. In today's session, we'll talk also about key things you need to think in mind when you're trying to collect your data, and then obviously selecting the right charts. So first, a key principle is when to use control charts. So in many organizations today, because let's say we are in an age of information and we are probably swamped with data more than we've ever been. So you may have already a lot of data being produced, some metrics, some dashboards. And so you may have to have a conversation with your process owners or your stakeholders to figure out, can you reuse those? Or do you need to have an additional improvement on those dashboards or chart as it is? Now, those are probably things which are already well established in terms of who produces them, who reviews and communicate them. So you have to be careful. They are sometimes done for a particular purpose that may suit your project or it may not. Equally, if you want to change them, you probably need to go through a certain amount of governance to make that change happen. What is most common is for people who are in a world of I need to create a control chart from scratch, it's as part of an improvement project. And so depending again on how mature your business is and how rich it is in terms of data, you might find yourself in using control charts throughout a DMAIC framework, and obviously you'll need to translate to PDCA, AD, or PPS. But the concept is that effectively in Define, if you already have your data and it is the right metric, use it to enrich your problem statement in your project charter so that you get good contracting with your stakeholders and your team. In measure and analyze, this is where if you don't have a good metric, you're going to have first opportunity to go collect that data and see how the process is performing. Is it stable? Is it not? What can I learn from it? Is there some significant segmentation that I need to be worried about? And then in improve, you can also use control chart to start assessing how the pilot of some of the options that you had designed with your team are performing, because again, it's a very good visual element to do that. And obviously in control, this is after full implementation of the changes where you can articulate the improvement visually that you've made. One caveat here, this is about showing the change. If your change does not look obvious, as in improvement, good or bad, The control chart will not tell you that for sure. It tells you that you may need to go and check. And this is where there's a big difference between a control chart, which are graphing tool, and statistical test, which will give you a definite answer whether or not there's a statistically significant difference in the before and after of your implementation. Okay, I just wanted to make that clear. So how are control charts structured? There are different control charts for different type of data, and I will talk more about that in a minute. But there are some common aspects across all those control charts. The first one is obviously you're going to have your actual plotted data. Now, in Minitab, which is an example here, it comes up in blue. In yours, it might be black. It doesn't matter. This is the actual data from the process. And then you're going to have a center line, or sometimes referred to as central tendency. And this is calculated based on your data. So depending on the nature of your process, you may have, again, continuous or discrete data, which I'll talk more about it. And so even in the continuous world, you may sometimes use a mean, you may sometimes use a median. So the central line will always be there. The actual label of it will vary depending on the chart you are actively using and how you set it up, obviously. And then the third element, and probably the most crucial, is the control limit. So those, again, are calculated by your statistical software on the basis of assessing the amount of standard deviation. The first basis is 3, but there's also an element of constant, which are taken into consideration to assess it based on the sample size that you have. So it's not, if you do this in Excel, yes, I know we typically oversimplify and we say it's center line plus or minus 3 standard deviation. And that will get you a ballpark. The actual calculation of control limit have additional layers into it. Hence why you will always see some differences between a manual control chart done in Excel and a proper control chart done in a statistical package. These formula exist. I'm not going to go in detail because that's very advanced, but if that's what you need, please let me know and I'll be happy to share them. Those control limit can be smooth or flat, if you want to use that term, when your population overall is stable or your constant sample size, or they can look broken, so they will stagger a bit, both upper and lower, or maybe just one of them if you have a boundary, to represent the fact that your sample size is varying. And that can be quite useful because you can see then how your process is performing in a varying volume of transaction that comes in. And for some businesses, that was the first realization that they needed to better cope with the volume of business. Okay, so don't worry if you get broken line. This could be a really good thing for you. Now, another thing around control limit, just again, in case you haven't had the full CI training or it may have been a while, we refer to as upper and lower control limit, or UCL and LCL. And that's effectively the voice of the process. As I said, it's calculated based on your data. These are not to be confused with the upper and lower spec limit, which come from the voice of the customer. So it's something that you gathered, you defined, you agreed, but it's not calculated. So there's very different. Now, there are techniques where you can include and show, again, some of those thresholds if you want, and I'll allude to that in the companion video on how to build a chart, but I'll show you an example at the end. And then finally, and probably most importantly, based on all this data and this calculation and the set of rules, which the giants before us have defined, we can identify signals of excessive variation or unusual patterns, okay? And again, in the Build and Analyze module, I'll explain a lot more around those patterns. But those signals are your friend, and they will show up if you select All Test when you build your chart. So I alluded to, we have different charts for different data. Let's look at the type of data. This might be a refresher for you, or you may already know it, or it may be the first time. If this is something brand new information for you, I would probably encourage you to go for a proper CI training, because this concept will come in a lot of other tools that are used when working with data. So it's worth. So I'll just point out a few things, mostly for language and alignment. As I say, if you want more information, I can create a module, let me know. Or I would generally say I probably need to go through the full training. First type we play a lot with is continuous or variable data. And this is data we measure. It has a unit, and this division of that unit is meaningful. So you can go from year, quarters, month, weeks, day, hour, minute, seconds, millisecond, nanoseconds. So these are things that are going to have distribution. Depending on the nature of your process, the distribution can be normal, as shown here with the graph on the left, or it can be non-normal. This is an example of log normal, but also very common in business. If you deal with call centers, call waiting time, call handling time will frequently look a lot more like the graph on the right than the graph on the left. We can use both. That's the good news. But just obviously a control chart on this sort of data needs to be analyzed a little more carefully. And then the second type of data is discrete, or sometimes called attribute data, which is data that we count. And within discrete, we have two types. And very originally, the first one is called type 1. These are type where we put in categories. And within that type 1, there's also another two options. You could have binary data. So that's your simple yes, no, pass, fail, late, on time, good, bad. Frequently, you'll use pie chart to show these. Or you could have nominal categorical data. And this is where you're going to count typically your defects or defective within each categories. And the order in which these categories are presented makes no difference. They're independent. The categories themselves are independent. So frequently, those are shown in some form of bar chart. It could be another pie chart too. It depends on what you're showing. Type 2 discrete data refers to ordinal data. This is where you are counting defects most often, and they have a single definition, volume options, and those will need to be presented in the order. So count 1 defect, 2 defects, how many times they had 1 defect, how many times they have 2 defects, how many times they have 3 defects. And you need to leave them in that order. Otherwise, the graph makes no sense. Okay, so that's why we refer to as ordinal data. Hopefully this just helps a little bit because it will be relevant when we go select the graph. Behind these data, obviously, because they have different properties, we therefore have different rules that we can test the data of the process against. And there are sets of assumptions that go with them. Now, a lot of the rules and assumptions are shared between continuous and discrete, and a few are just unique to the continuous data type. So I'm going to start with that one first. And then discrete will look very simple. Taking the example of Minitab here, this is where you can see what tests are available for you to apply to your data set. Depending on the version you have, it may look a little different, but the concept is the same. You have the list of the rules, and then each statement has a reference to a K. The K is a number. And instead of typing it, because they kept changing it over time, they decided to show that number in a separate column. The way you read this is rule number 1, you have at least 1 point which is greater than 3 standard deviation from the center line. And the 3 is listed here. Rule number 2, you have 9 points in a row on the same side of the center line. This is where you may effectively start to have a process re-baselining, so to speak, and so on and so forth. So obviously, as you can see here from the numbers, if you don't have the number of data points that would match this, maybe you only have 10, you might ask yourself, oh, do I need to then ask not to use it? My suggestion to keep things simple, especially if you're going to automate this, is leave as perform all test. Most statistical packages are smart enough that if there isn't enough data point to actually use a rule, they're not going to run it and respond about it. And it's only when you're going to have enough data point that it will actually use it and assess. So this is where sometimes your control chart, as you get more data, start to evolve. It's completely normal. If you build this manually, this is the part which is hard. And this is why I say just use the statistical package, okay? It's probably not worth the amount of effort in recoding to get this amount of information. So let's talk about the assumptions which we need to be aware of so that we can use the control chart effectively. The first point is your data must be made of independent data point. Now, what do I mean by that? The best way to do it is to explain with an example. Let's say I'm looking at a loan application process. I'm using an IFA. I'm trying to get a mortgage from a bank. I think I know which bank I want, but I have different options around the mortgage. I could do it for 20, 25, 30 years. I want to see what will come up for me. The IFA and I are effectively going to put out 3 loan applications, same bank, same customers, but slightly different parameters. When that gets to the bank to assess, if the IFA and the system work well, all the information for each loan application should be on each application. Sometimes we have system goof up or we have misunderstanding, and you will have people that put all the information required on application 1, especially about the customers, and then forget to copy or replicate it in application 2 and 3, and only put the additional information relating to the mortgage type parameters. And so what happened is application 1 is going to go through, it has all the information, it's clean, it's probably going to go on a standard path. Application 2 and 3 are going to start in, and then they're going to be checked, and they say, oh, I'm missing a lot of data. So they're going to be sidetracked and they go on a different path. That's how it should happen. Now, sometimes the assessment of whether you have a good or bad application is much, much, much later in the process. So you have 3 applications going through that may or may not be handled as a bundle. And therefore, you're going to have all sorts of funny things happening in the process. And the fact that application 2 and 3 potentially will take longer is very dependent on the fact of whether or not it was processed with application 1 or not. Now, there are lots of other options and realities where you have many variations of this theme. But the concept is my data point, and this is particularly relevant for the individual moving range, is it independent from the previous or the next? If the answer is yes, it's independent, it's not related, it's absolutely fine, great, brilliant. If it isn't, you need to assess. And this is where sometimes getting a sample might actually be the better option for you, because by taking a sample, you're going to have such level of randomization that you may make things independent. Or if it's a common practice, by taking a bigger sample, you're going to actually take out the bias of this quote unquote abnormal way of working. So it depends what you want to do, but there's different options to cope with it. And obviously that depends on your circumstances. Number 2, definition and data needs to be stable. Data collection needs to be stable over time. So I think this one is pretty self-explanatory if you've ever done data collection, but I'll explain that a little bit more later on. Please be aware that if you change the way you collect your data or the definitions or the scale on which something is rated, and then you get that score back, these are the primary example of things which are not stable. So you, at best, need to create phases in your control chart so that you don't compare apples to oranges. That's assuming at least the scale is the same. If you also change the scale of measurement, you really need to put another different control chart. And then have at least 10 to 15 data points. And I think this one is obvious from the test shown above. The one rule which is really specific to continuous data is the fact that we would ideally like your data to be normally distributed. Now, it doesn't need to be perfectly normally distributed. If it's fitting the empirical rules of normal distribution, that's great. Again, this is where you might need to play with your sample size so that you can go and approximate your data to be normally distributed. So I would refer you back to the rules around normal distribution so that you can assess your sample and your data against them. For discrete data, almost by nature, due to the limitation that we have with this sort of data, as expected, we have fewer tests that we can perform, and proportionally also, obviously, we have fewer assumptions, but they are still there, and I want you to be aware of them. So let's go into now what we need to prepare for a good data, because your control chart will only be as good as the data in it, right? So you need to spend some time with your process owner to really agree on what are we measuring and why, and where are we going to pick it from. So if you're a visual person, this is why I wanted to show you using a process flow, because depending on where you're going to take your measurement, you may get different values. Now, they may both be correct, but what insight are you trying to give back to your audience? That's what you need to start with the end in mind to assess whether an existing metric is good enough, or do you need to go and collect a new one that is better and more relevant. So there are then lots of consideration, and I'll go into that in a secondary slide. As I alluded to, that reliable and stable data collection. So if you change your measurement system, whether you collect now, instead of manually, you go digital, you change the application that you use to collect voice of customer and customer experience feedback, you need to keep aware of those because they will create bias and changes. I had an example where a company started on a 1 to 10 scale and went back then to a 1 to 5 scale. And guess what? It didn't simply just divide the score by 2. There was a significant shift, because before it would have been quite easy to get a 7 or 8 out of 10, but suddenly it was getting a bit harder to get a 4 out of 5. And so it felt like they were getting worse, when in fact, they had literally just changed the data collection method and definition. So once we had that conversation, it was easier, but it meant that a lot of the previous data had to be taken out, and we used a commentary to explain that. And then once we had year-on-year data, it was a lot easier. And then, especially if you are planning on handing this over to a process owner or process management team, you need to start thinking toward building a framework that will consistently produce, review, and act on those control charts. Control chart is a very good tool, but it's only as good as how it's being used. So your job when you create a control chart is make sure it's correct and fit for purpose, but frequently you won't be the one using it afterward. Unless you're here and you're a process owner, then by all means, you will have full control of it. I applaud you for taking the initiative and trying to really understand those control charts. So how do you define a good metric? Now, if you come from the wonderful world of CI, you'll be familiar with something called the CTQ, critical to quality. These are the primary things that we put on control chart because they help us directly monitor the process performance. As you go through cycles of process improvement, we then start to identify key factors. We think of them as root cause or critical factor, who also deserve to be plotted because if we manage the X, we will control the Y. So this is where you frequently start plotting your Y, if I can use that terminology, or CTQ. And then you're going to start plotting also your X or key factors. Okay. And these may be referred to as KPI. Either way, they're both metric, but the meaning of them might be different for different people. So I just didn't want the terminology to offend you. So I've used metric to cover both situations. Either way, this should be meaningful. It should be important. It should add value. Measure what you treasure. So the when and where, we talked about it using the process flow. So I'm not going to cover that too much, but I will just point out that if you are, for example, plotting duration, so a length of stay, a lead time, a cycle time, a processing time, which has a start and end point, you need to be really clear about the definition of those points and how to collect the data and what is used to timestamp and the fact that it is stable and reliable. Also, you will need to decide whether you're plotting based on when you start the clock or when you stop the clock. There are a few processes out there that work on the basis of duration of response to deadline. So different people I've handled the situation differently. Some people still measure based on how long it took for a customer to respond based on when they sent the message. However, because more and more we get multiple messages, that made things a bit complex. So they decided to swap and they still measure the duration of the response of the customer, but they do it to the deadline. And so what will happen is if you have multiple deadlines over time, then you see what sort of time I tend to get. So different people need to do different things. There are options. They can all be supported, but you need to do the thinking about it before you start creating your chart. The other very common question you need to anticipate is, what is the frequency I want to be showing on my graph? Different circumstances will call out for different things. And this is where effectively it needs to be in line with the volume of processing and the frequency of it. If you have something which takes seconds, and you have very, very, very high volume, you're probably not going to show it on an average per day. Now, maybe you will, I don't know, but it's unlikely. On the other hand, if you're building a power turbine who takes, 18 months to 2 years to produce, probably not going to show how long it takes every day because it might not be relevant. So that's what I'm saying. It's just keep it in line with the nature of your process. And then what unit you're going to use if you have continuous data, and or how you're going to define your defects and or defectives if you're using discrete. So again, for a lot of people say, well, that's obvious. I'm like, well, for many it is, and I don't want to overcomplicate. But for others, they need to start thinking, because if you have a situations where you have very wide range of values, and this is more likely in a continuous world, if you have calls that can take anywhere from 30 seconds to 180 to 300, how are you going to average that? Are you going to still keep it in second, or are you going to keep it down to minute, right? So look at your process and make the right call. And then if you need to sample, as I said, not everybody does, really think about your sample size, making sure that it's relevant, and also think about your sample strategy. How are you selecting your samples to be accounted for? It's a significant conversation. Again, I have planned to create this as a separate module. It's frequently part of the measure part of a DMAIC type training. So if you need more information on that, please go and look into it. But I just wanted a thought for you. And then finally, again, may not always be relevant, but if it is, it's definitely worth giving some thought about, is do you have any significant segmentation? So by segmentation, I mean a practical difference in how the process works at different time of the day or time of the week, or depending on the nature of your transaction. So going back to my loan application, I did allude to a standard application versus non-standard application. If an application goes on those different paths, the team who manage them are slightly different, and they also have different spec limit, because I expect a simple application to be done in a matter of hours. A complex application, I'll give them some days. And obviously, it's not fair, therefore, to put both of them on the same control chart. It will give you a very unstable process. I can give you that upfront. So if you know those sort of segmentation, anticipate them. When you collect the data, if you're not sure, at least collect the factor to recognize them, how they rate on that. Do your first control chart with the data combined, and then split the data and do a control chart for each segment. If you see that your process becomes stable after you split the process, it probably tells you that the segmentation is relevant and should be continued to be used through the rest of your analysis. It also gives you much more relevant route for improvement, and people will be more responsive because you've taken into consideration their existing reality. If you want more information on this sort of thing, as I said, let me know and I'll develop some modules around it. So you've got to answer all those questions. You got your data, how you select the right chart. So this is effectively the point where you'll see a bit of repetition between this module and the next, because again, I wanted to make sure everybody had the same data. So question 1, what data do you have? Let's assume you get continuous data to start with. Your next question is going to be, am I collecting individual data point or am I collecting things in group? If you have individual measurement, so this is, for example, what's my weight every Friday morning? Every Friday I weigh myself and I take the measurement and I plot it. This is going to be using an individual moving range chart. Very straightforward. You've seen an example of it. I'm not going to elaborate on that. If, on the other hand, you are taking groups of measurement and you're looking at average within that group, and then you're plotting that average every day, this is the world of the X-bar chart. Now, depending on the size of your group, the sample size, if you have a sample size which is less than 10, we would recommend that you use the X-bar and R, which R stands for range, because the range becomes a better measure of the amount of variation that exists in your process. If, on the other hand, your sample size is greater than or equal to 10, we would suggest that you use the X-bar and S, where S stands for standard deviation. The X-bar is obviously the mean. On that basis, that because you have at least 10 data points within your sample size, we can have a reasonable, relevant standard deviation being calculated. You could do it on less, but it will be very sensitive to outliers. And when you have a small sample size, you tend to have more opportunity for outliers. So the range is a little bit better from that standpoint. On the other hand, if you have discrete data, your second question is going to be a little different. Here, we're going to ask yourself whether you have defects or defectives. On those are two, same thing. Not exactly. In plain English, outside in a world, probably. In CI, they're not. Defective is an item where you can have good, bad, yes, no, pass, fail, late, on time. No other middle value. This is going back to the data type. This is your binary data. The third question you ask yourself, assuming you're on that branch, is, do I know both the bad and the good? Do I know the full population? If the answer is yes, then the last question is my sample size constant? If that's your situation, then great. You're going to use the NP chart. If your volume is evolving and you're capturing the total population of yes and no's systematically, then you're going to use the P chart. Hopefully straightforward. Obviously, there's another branch for defects. Defects, remember, is when you're going to count the number of occurrence of a defect type, either within categories or overall. The third question when you're on the branch of defects is going to be, is the probability of defects low? What do we mean by low? Well, different people have different view. I would encourage you to use a threshold of about 30. And I'll come back to that later on. But let's assume that typically on a given day, you get less than 30 defects. At which point, your next and final question is going to be, is my area of opportunity for defect constant or not? If the answer is yes, you would use a C chart. If the answer is no, you'd use a U chart. The area of constant opportunity for defect is another concept where people which are not familiar with process improvement sometimes struggle. And this is easier to explain in a manufacturing world. So I'll have to apologize. I'll try to find a service example as well. Let's say I'm a body shop and I do the painting on the cars. If I'm a very, very specialized body shop and I only deal with one car model, for example, I only do Subaru Outback. That's it. I don't do the WRC. I don't do the Cross V, just the Outback. Then it's always going to be the same car, same areas of opportunity within a few millimeter squares. And so at this point, I can count the defects, and it's always going to be looking at the same surface physically of paint on which I could have had some scratches. In service environments, it's a little difficult to find, but there are examples. Frequently, when we look at rate of claims or rate of complaints, there are some element where we can use this. But very commonly, obviously, as you probably gathered, I'm a paint shop. I'm going to accept pretty much any car that needs painting, which means I'm going to have different make, I'm going to have different models. So my area of opportunity is always going to be different, at which point I'm going to use the U chart. And this is one where obviously we have a wide range of that in service as well. Invoicing, there's sets of fields which are very standardized, that are always constant, and we always assess the number of defects based on those fields. What changes is the number of invoices. So we could potentially go with the C chart. Now, on the other hand, if I'm doing a sales order has a few key fields which are standard, and they can only take one value or another and be correct or not correct. But then there's a whole series of fields where, well, you could have X amount of defects. Some people order 1 item, some people order 20 items. So the areas of opportunity for the sales field is going to be varying, at which point you go to the U chart. You need to play with it a little bit. You really need to understand the process. You really need to understand how the data was collected, so that you can select those charts. This is why I went through those previous slides, because you can see now you need to be able to answer those confidently so that you select the right chart. Now, you ask yourself, well, what about if I'm in the no branches? Well, that's almost simpler, because then whether you have a high volume of defects or you're in a situation where you can only measure your defective, regardless of their volume, then all you're going to be using is the individual moving range chart. So from that standpoint, in a way, it's better. But again, because it's just in moving range, there's an element where you will be hiding, which is, does my volume of defects or defective changes based on the volume of transactions? So be aware. I've put this slide here as a reference so that if you want to add examples, then you can have them. It's for you to refer to it. So let's look at some example of what those charts would look like. So we've already seen the example of the individual and moving range chart, where at the top of the chart, you got the individual section, which is the actual data plotted. So on this day, I had this decision lead time for that loan on that day, and so on and so forth. You see my central line, you see my control limit, because I'm plotting every single loan. Things are, and then here at the bottom, you got your moving range. So the moving range is calculated based on the difference between those 2 points. And then it plotted obviously from point date number 2. This one is the difference between those two, which obviously is 0, again, 0, and so on and so forth. So you could have a very stable process here, but sometimes it's the moving range that goes out of control. And that tells you that fundamentally you're performing probably okay, but you have issue with variation. So go find out why, because frequently the root cause of one may not be the same as the root cause for the other. Now, if you are in a world of sampling, this is where you're going to have an X bar. In this example, is the X bar and S, and you can see what I mean by the broken line. And this is where it allowed to detect, based on the size of your sample, whether the performance is experiencing excessive variation, like in this case, versus here it looks similar, but due to the sample size, it was within the control limit, so it didn't get flagged. So this is where having the actual sample size can be really interesting. And then we have the charts for discrete. So this is a C chart where we have, again, constant areas of opportunity. So obviously this is something which shows quite interesting patterns, above and beyond the fact that obviously we have things which are outside the control limit. And then here you have different team. Obviously, we see the same pattern, but none of the data practically is within control limit. So very, very out of control process. And for example of control chart for defective, we have the NP chart with a fairly constant total population. And we have the P chart, which is then we have varying volume of total population for defective and non-defective. And so you see how the process is performing in relation to that. So hopefully this gives you an insight. As I said, how to build and analyze will be developed in the companion video, so I'm not going to take too much time here. Just wanted to point out a couple of other elements. So within statistical package, they decided obviously to enrich things and give you options to show how things evolve and create that really engaging picture. So you could use things like phases to show how the process evolved. And in Minitab, it's called stages. In Jump, it's called phases. But it does the same thing. And it's important because if you use this sort of option, it will not just only create a line, but it will literally recalculate the control limit and the central line for you. If you just want to see a line as a reference to a particular date, then you can use the option for reference line, which at this point shows the line, but it doesn't recalculate things. I'll explain that again in the other video. And then another very handy options here is, again, that use of the reference line, this time on the y-axis, so that you can see how your process is performing against a customer spec limit. Now, in this case, imagine if this is an upper spec limit, where my customer wants an application decision lead time in less than 10 days, clearly this process is not performing. And this is why if you can enrich your control chart to help people understand how to make sense of it, rather than having you to always explain it, it will be a lot more powerful because people will take ownership. And it's really important that everybody else is on the same page. And that leads into the whole control plan and how to make sure control charts are continued to be used going forward. So I'll create a link for this particular module in the description because I didn't want to make things too busy. If this was useful, please like and subscribe. As I say, there is many more modules coming up. Use the comments to let me know which topic you might be interested in or questions you have, and I'll try to prioritize those. And then for information, these are the link to the videos on how to build and analyze the control chart in Minitab. For continuous and discrete data, I will be doing different modules for different platform, obviously, because the instructions are a little different. The analyses are not. So if you are familiar with your own platform and you just want to refresh how to analyze them, then these might still be relevant, but I just want to be upfront that they're built on Minitab. I would encourage you to be self-sufficient and resourceful. Go and look at the help menu that you have in your own statistical package. There's frequently a lot available there, either in the system itself, in the help menu, or on the provider websites. For example, Minitab has both. And if you go on support.minitab.com, there's a whole library of additional training for you, which is free. I hope this is useful. I've done my part. Now you need to go and do yours.